Now in this video, I would like to illustrate with the example of a portfolio of bonds how interest rate immunization actually works when we manage the interest rate risk of a single liability. So let's say I have this portfolio of 3 bonds. Okay, I have bond A, bond B, and bond C. Okay, so A is a 3-year bond, B is a 5-year bond, and C is a 10-year bond. Right, and the coupon rate is as follows. Okay, and then we have the payment frequency. I'll assume it's semi-annually, and then these are the price per 100 par. Okay, so let's say if just for practice, if I want to get the yield to maturity, Excel has a very easy function for that. So the N per here will be the number of payments, so there will be 3 years times 2 for semi-annually. Then in terms of coupon payments, it will be 2.2% times par. Let's assume it's 100. Okay, then we'll divide by 2, and for PV, this will be negative of the price. The future face value is 100 par. Okay, and then I'll just leave this as 0, end of the period. Okay, and this is our yield to maturity, but this is for half a year. So if I want to analyze it, I'll multiply by 2. Okay, so that's per year. Now just copy this over. So we have the yield to maturity per year. Okay, and we assume that these bonds were just issued today, and this is their tenor. Then I assume that, okay, I'm going to allocate the par value according to this pattern: 35 million for A, 20 million for B, and 65 million for C. Okay, so that's a total par value of 120 million. And the market value will be based on the par value multiplied by the price, but we have to divide by 100 because this is per 100 par. Okay, so that gives us the market value, and then I'll just sum it again. So that's 120.17 million. Right, the allocation here will be based on the market value. So I'll just take allocation, divide by the total market value. So we have this percentage here. Okay, and then this is the Macaulay duration of each of the bond as well as their convexity. Now what I'm gonna do now is I'm gonna build the cash flow schedule. So I'll start with T. Okay, we have T from 0. I will name all these in semi-annual periods, so it's 1 and 2. Okay, 2, and I will drag this all the way up to 20. Okay, so 20 means 10 years in 20 semi-annual periods. Then we have the cash flow for bond A, the cash flow for bond B, and the cash flow for bond C, and then the total cash flow. So initially there will be an outflow where we buy the bond. Okay, so there will be an outflow there. Okay, so here we have the total outflow, which is the total purchase. So I will sum up these 3. So that's my total market value, okay, of the bonds, which is also the outflow. Right, so now I will calculate the coupon payments. So for bond A, that's coupon rate divided by 2 times the par value. Right, then I have the numbers here, so I will just copy this over to the right hand side. Okay, so we have the same number here, just remember to divide by 2. Okay, and here we have 1.82 million. Okay, and then lastly we'll just make sure we sum it up. Alright, so now we can start to copy the numbers in. Now do be careful though, because it is 3 years. 3 years times 2, so it will go up to year 6. Okay, and for bond B, it will go this will go up to year 10. Okay, period 10, because it's 5 times 2, and then for C it will go up to 20. Okay, because of 10 times 2. So of course in the final period there will be a par value that you have to add in at the bond's maturity. Okay, so I'll just add in the par value. Right, so we're done. Okay, so we have all the cash flows in, so I'm just going to calculate the total now. Okay, just drag this down. Right, so we have all these numbers. So the first thing that I'm going to compute now is the what we call the cash flow yield. Okay, so the cash flow yield here is the equivalent of the IRR, the internal rate of return of the portfolio's cash flows. So I'm going to use the IRR function. You can use your financial calculator as well, but it's faster to show it via Excel. Okay, so from this it's 2%, 2.4373%, but this is for half a year. Okay, this is for per semi-annual period. If you want the annualized number, you have to multiply by 2. Okay, so that's 4.8746% per year based on the whole portfolio's cash flows. Now, sometimes some people would actually use a weighted average of the market value over the yield to maturity to get the yield to maturity of the portfolio. Okay, think of it as an estimate to the cash flow yield. So if I were to use a weighted average YTM, okay, if I compare it to, let's say, I'll take some product, I'll take the market value, all right, and then I'll multiply that to the yield to maturity, and then for the whole sum product, I'll divide it by the total market value. So that's actually 4.3257%. Now, when you read through the textbook, there is one observation that you will see, which is when the yield curve is upward sloping. Okay, you see that the yields are actually increasing. So when the yields are upward sloping, the cash flow yield will be greater than the weighted average, okay, the market value weighted average of the yield to maturity. So this is how it is illustrated. Okay, so the what they call this, the more upward the curve is sloped, okay, the more the yield will be concentrated towards, okay, the yield of the longest maturity bond. Okay, so we can see that there. So if we were to take a weighted average YTM using the market value, then it will actually introduce a bias, or it will introduce a model risk to the portfolio. Okay, so that's one observation to keep in mind. Of course, if the yield curve is downward sloping, that means the yields are declining. Okay, then you will see that the cash flow yield will be lower than the weighted average YTM. Okay, so that's that's something that we can observe through that. Now let's proceed. Now, other things that we can do is I can now compute the PV of the cash flow. All right. So what I'll do is I'll take this cash flow, I'll divide by 1 plus the cash flow yield. Okay, I'll log this in, divide by 2 for half a year, and then to the power of T. Okay, so this is for one semi-annual period, and then I'll just drag this down. Okay, so we have the PV of each cash flow. So how do I know that I'm doing the right thing? If I sum up the cash flows, I should get the same amount here, which is 120.17 million. Okay, so that means I'm doing the right thing here. Okay, keep in mind IRR here means that the discounted cash flows should be equals to the initial value. Now I'll then convert this PV into a weight, okay, the weightage. So the weight here would be based on the PV over the total market value, or the total PV. So this is the weight, okay, of the PV of the cash flows, and of course it should sum to 100%. Okay, and then now I'm going to calculate the Macaulay duration. So I'll take the weightage times the time period. Okay, so I'll take the weight times the time. Okay, I will click on this and sum up, and then I will just drag over. So it's 12.016 here. Now I'll just create a row. So of course this is not this is the Macaulay duration, okay, 12.016, but this is in semi-annual periods. So if you want to get the Macaulay duration, okay, of the portfolio, you will take the sum, but then we will convert it to annual period, so we have to divide by 2. Okay, so in this case, if I just keep to 4 decimal places, here we see that the Macaulay duration of the portfolio is actually 6 years. Okay, so in other words, this portfolio can be used to hedge the interest rate risk of a single liability which is due in 6 years time. Okay, almost about 6 years there. Okay, so that is for the interest rate immunization purposes. Now I'll illustrate how the immunization works shortly, but for now let's look at 2 more statistics, which are the dispersion and also convexity. Okay, but of course before that, I'll just like to illustrate that if I were to take a weighted average of the Macaulay duration using the market value, and then I will multiply that to the individual bonds Macaulay duration, and then divide by the total market value, so that will be actually less. Okay, again we see a similar observation here. When the yield curve is upward sloping, the Macaulay duration of the portfolio will be greater than the weighted average Macaulay duration. Okay, which is why it's also telling us that it's actually quite dangerous to just take a weighted average of the duration, okay, using the market value. So this can introduce model risk, because imagine if I trust this result, okay, and then if I were to use this to hedge my interest rate risk, I will definitely get it wrong. Okay, right, so let's go over to dispersion. Okay, so next thing I want to introduce here is dispersion, which is something like a weighted variance. So how I'm going to calculate it is I'll take the weightage times the t, the time, minus the Macaulay duration. Okay, now, so this is how I'm going to do it. So I'm going to take the weight, okay, times the time period. But then when you minus, be careful, I'll take the Macaulay duration in semi-annual periods, because these are still in semi-annual periods. Okay, so I'll log that in, power of 2. Alright, just sum it up. And okay, this is my dispersion, but this is in semi-annual periods, and because I square it, so if you want to analyze it, you will have to divide this by 2 square. Okay, it's 2 here is for semi-annual periods, and square here is because we squared the difference. Okay, so this is the dispersion of the portfolio. Okay, this is what we call something like a weighted variance. Okay, let's move on. Now let's say if we were to take, now we'll calculate the convexity of the portfolio. So to do that, I'll take the weight times the time period times t plus 1. Right, so again I'll just rebuild it from scratch. So times t times bracket t plus 1. Then I'll just drag this down. Okay, and the sum here is 199.2684. Alright, so this is of course in semi-annual period squared. So if you want to get the convexity of the portfolio, you will take the sum here, and then now we will have to divide by 2 to the power of 2, because this is in squared terms. So you must divide by 2. 2 for 2 is because it's semi-annual, and the power of 2 because we squared, okay, the time factor here, the t times t is squared. Okay, now after that we are not done. Okay, we still have to discount the whole thing. We will have to divide the whole thing by 1 plus the cash flow yield, divide by 2 because of semi-annual period, and to power of 2 because it's a squared term. So this is your convexity. Okay, this is a convexity of the portfolio, which is a useful adjustment that we introduce if let's say we expect a large movements in the yield. Now if I just calculate the weighted average convexity, that would be the sum product, and then I will take the market value times convexity, divide by the market value. So that's again, you can see the result is quite consistent with duration. So the convexity of the portfolio is also greater than the market value weighted average convexity. Okay, so again, this is because of the upward sloping nature of the yield curve. Now finally, there is one formula that allows us to link convexity to Macaulay duration as well as convexity. So the formula would be using the Macaulay duration, but in semi-annual periods, the power of 2, plus the Macaulay duration in semi-annual periods, plus dispersion. Okay, so that will, if I stop here, I will be able to get 199.2684. If I just calculate this, okay. But of course, we don't stop there. We still have to discount by 1 plus the cash flow yield, divide by 2 to the power of 2. Okay, but it doesn't end there. This is still in semi-annual period squared. So I will have to multiply the whole thing, or in fact divide the whole thing by 2 to the power of 2. Okay, so that allows me to tie back to the convexity earlier. Okay, so this is a formula that you should try to learn. Okay, if this is asked in the exam, then it will be a straightforward one. Okay, now we're done for the major part of it. Just to show you a few observations about how to calculate the cash flow yield and compare it with the weighted average yield to maturity. Okay, and how they are different. Okay, they are not exactly the same unless the yield curve is flat. All right, so the next part the next thing I want to show you here is the the immunization part. What do we mean by interest rate immunization? So according to this calculation here, the portfolio Macaulay duration is 12.016. So in other words, okay, if I have a liability which is due at this period, which is about 6 years from now, okay, if I have a liability that's due around that point, okay, I just have to hold the portfolio up to that point, and the value of the portfolio at that point will be equals to the value of the liability. Okay, no matter whether the interest rate increases or decreases today, it doesn't affect the final value at this period. Now I'm going to show how that works. So to do that, I'm going to just create a few sample scenarios. Okay, first I'm going to assume that today the yield curve doesn't, the cash flow yield doesn't change. All right, I'll assume it doesn't change. So I'll just assume YTM okay, underscore 0 means no change. And then the other scenario will be where there is a change. Let's say the interest rate, the yield actually decline. Okay, decline by a certain percentage. Let's put X%. And then the other part is where the YTM actually increases by X%. Okay, and we'll see the impact on the portfolio value under these different scenarios. Now, just to make things simple, I will just link the cash flow yield here. And then for this part, I will put in an assumption. Okay, let's say, just to put a starting number, let's say the yield increased by probably 20 basis points. Okay, and this part would be just a decline, the same quantum but in different directions. Okay, I'll be using this shortly to build it into the template. Now let's start with the first part. So let's say if every time we receive the coupons, the cash flows, okay, not to say coupons, the cash flows, we will reinvest these cash flows up to the due date of the liability, which I assume now is at semi-annual period 12.016. I'm assuming I'm going to reinvest everything up to that point. So in this case, when I will calculate the future value of this cash flow, okay, I will compound it. So I'll multiply by 1 plus the cash flow yield. Okay, so let me lock that in, cash flow yield, and then I will divide by 2, semi-annual period, and then, okay, now when you raise the power 2, I need to invest it up to this period, okay, 12.016, lock it in, minus, okay, your current period, which is 1. So that shows how long we are going to reinvest it for. Okay, so that's done. So now what I'm going to do is, since I formulated it this way, I can now just drag it down to the last point. Okay, so of course when I drag it down, eventually at some point the power, the index will become negative. Like for example, in this case, this is actually 12 minus 13 because we went past the Macaulay duration. So in fact, the formula here would serve to discount the cash flow. That is why you will see that the PV, the future, is not a future value, but in fact this is more of a present value now. So I'll just color this in blue just to show you how it works. All right, so in fact now what we are doing here is I'm discounting the cash flow from period 13 to period 12.016, and the same goes to each of these. I'm doing discounting from these respective periods to period 12.016. okay, now I will copy this over to the next part by just to copy the formula over in case the cash flow runs. So okay, I'll have the same number again. Okay, here it's still linked to the cash flow and all, so nothing has changed. But this time around, I'm going to build in the shock, the change in the interest rate. So I'm going to just put a bracket here. I'm going to add in the incremental change. Okay, and then I'll just press enter. And now I'll repeat the same steps with the next column. Also the same thing, but I'm going to move the shock over to plus 0.2%. All right, so just to make sure everything is there. Right, so now don't forget to lock in the shock here. Okay, so just lock in the shock amount here so that when I drag it down, okay, it will be consistently copied over. So now I'll calculate the sum, okay, of the present value and the future value. So here the initial assumption is that if the cash flow yield doesn't change when we buy these bonds, and it doesn't change all the way up to the Macaulay duration, then the value of the bonds at the Macaulay duration is, which is 6 years from now, is about $160.495 million. Okay, but if let's say there is a decline of 20 basis points in the cash flow yield, then the value of the bond portfolio will be 160.498 million. Okay, but what about this? What do we expect this to be? So if I copy this over, you will see that the total is about the same. Slight difference there. It's about 160.498 million as well, okay, with some minor differences at the back. Okay, but this is because we didn't factor in, there's some error there when we use duration. Okay, but if we have the convexity adjustment in, it should be quite close. But anyway, here it shows that regardless whether there is a yield decline or yield increase, the future value of the bonds at the Macaulay duration period is actually almost the same. Okay, it's almost the same, so it doesn't matter whether interest rate went up or went down. Okay, but of course we assume that these shocks here only happens instantaneously when we buy the bonds. Okay, it doesn't capture the impact should the yields change after that. Okay, so that's a wonderful thing about immunization. If you hold it up to that Macaulay duration. Okay, but of course every day the Macaulay duration will change, and then we have to rebalance the portfolio. Okay, but it in a way it gives portfolio managers a mechanism to determine, okay, whether what is the Macaulay duration, how long should I hold it for the price risk to offset the reinvestment risk. Now, of course, I could increase the shock to 0.5%, and you will see that the values under both a yield decline and a shock, positive shock. Okay, the values of the bonds will be quite close. Okay, at the Macaulay duration period. Okay, so hopefully through this video you get to see the illustration of how interest rate immunization works. Okay, and what is convexity. Okay, or the dispersion or Macaulay duration, and of course minor thing in case if you're wondering how do we get modified duration. Modified duration will be based on the Macaulay duration, and then we divide by 1 plus the cash flow yield and divide by the compounding the payment frequency, which is 2. So this is your modified duration. Okay, so how do we interpret this number? So assuming that the cash flow yield increases by 1%, then the bond portfolio value, the whole bond portfolio value, will decline by about 5.865%. Okay, so that's the expectation. Okay, and of course we can build in convexity as well if you want to measure the change in the bond value given a large yield change. Right, so that's the end of the video.